All right, last video on chapter 3. How many solutions are there? 3, 1, 3. Okay, we've solved a lot of equations before, systems of equations. I'm not going to solve question 45 right now, but I did just want to leave it on here as a reminder. I know you have in the set of problems some regular systems to solve. We know when we're solving systems, we generally have 3 methods we use, right? Um, we know how to solve, well, actually, there's 4. There's substitution, um, elimination, graphing. I guess the 4th is, some people would argue, equal values is a different thing, but I kind of call that the same as substitution. Totally up to you, right? Like on the left, the very first one, I would probably use substitution, if you will, or equal values. Depending on what you call it, right? Left side equals right side. Actually, I don't think I would do any of that on the first one because they're 2 lines and you can tell the slopes are the same, but they have different y-intercepts. So these are parallel lines with no solution. That's kind of easy just to look at and see. The second one, you have a quadratic equal to a line. So I would set them equal to each other, get everything on one side, and factor. The third one, same thing. In this case, it's a little different. So I'd probably do some substitution, right? Replace the x with that, move everything to one side, and solve a quadratic. On the last one, some substitution as well. It's a little bit more algebra heavy. One thing to remember, don't forget, systems of equations like these have the solutions are coordinate pairs, so like x, y points, like there is an x and a y that makes it true. If you recall from the last section, you know, if you have just a single line, there's an infinite number of solutions to that line. If you have another line, there's an infinite number of solutions to that, and when you put them together, they cross. And when you have equations in 2 variables, your solutions also have 2 variables. Depends on the shape on how many times they're going to cross. So we're going to start talking about this system. We're going to consider this system. The top equation right here, this is a circle, and the bottom one right there is a parabola. So if we're thinking about this, how many times do we expect them to cross? Well, we have 4 options, right? We could have, let's see here. If we have, you know, circles, when we think about this, we have circles and we have a parabola, right? They could never touch. They could touch in one spot. They could maybe touch twice. They could touch, whoops, I'm gonna have to back up a second because I need another circle. They could touch, say, 3 times, and they could actually touch 4 times. There's a lot of options. Right, and this is just me quick sketching, but if you have a parabola and a circle, we have a lot of choices. In terms of making a prediction on this one, I know the circle is centered around 0, 0, so, and the radius is 5. I can see the quadratic has a axis of symmetry of the y-axis because it doesn't shift left or right. It's just moved down 13. So I am going to assume that they will cross, and I will probably assume they're going to cross 4 times. So my guess is 4. We are going to solve this by graphing and see what happens. We could graph this by hand. We can also look at Desmos, which is what I'm going to do right now. And here it is. We have actually 4 solutions, there and there. This, again, circle is centered at 0, 0 with a radius of 5. And the quadratic has a vertex of 0, -13 and a normal scale, so they are going to cross 4 different times. Okay, back here. Whoops, sorry, not the right place. So was my prediction correct? Yes, they crossed 4 times. All right. So we need to also consider the idea of solving these things with algebra. So what it's asking us to do is make 2 different equations. One of them where we're dealing with only having the variable x, and another one where our variable is just going to be y. So we've got to do a little bit of substitution. If I'm going to think about only having a variable of x, then my y is the thing that's going to be replaced. So if y equals x squared minus 13, and I'm going to write this just in the variable x, what I'm going to have to do here is have x squared, right, plus, well, originally we have x squared plus y squared equals 25, but we're going to substitute for y squared. What we're going to replace y with is x squared minus 13. So we have x squared plus, in parentheses, x squared minus 13 squared is 25. Get rid of that one right there. Okay, all in the variable x. If we're going to write a different equation only in the variable y, how are we going to write that? Well, I'm thinking about the fact that we don't know, well, we have an x square in both equations, right? There's an x square here, there's an x square here. I guess you can't see what I'm writing. That has an x square and that has an x square. So we probably want to substitute there. That said, I know that in the bottom equation, x squared is the same as y plus 13. So x squared is y plus 13, if I rewrite that one. So I could actually do y plus 13 instead of my x square, plus my y square is 25. So 2 different equations solved for a single variable. Which would be easier to solve and why? I would definitely pick the y equation. So the highest power in the equation with y is 2. So it is just a quadratic to solve. If you look at the one on the left, because of this exponent right here and this exponent right here, that actually is an equation in the 4th power, and it's a pain in the butt to solve, though it can be done. So if you haven't already done so, it's asking you to solve one of these from part C. So I'm going to pick the one on the right just because it's easier. We've got y squared. I'm going to rearrange things, plus y, and I have 13, but I'm also going to take off 25. So I've got minus 12 is 0, which would mean if we're factoring y plus 4 and y minus 3 is 0, so y is negative 4 or y is 3. Solving isn't done, that's just finding the y values. So if we found the y values, we are going to need to plug them back into an equation to solve for the x values. In that case, which equation is easier? Kind of just depends. I guess I'm going to go with the one on the bottom. Just because I am. So the bottom equation, if we think about it, is y equals x squared minus 13, right? So we're going to have to do this 2 different ways because we have 2 different y values. So this is going to be negative 4 equals x squared minus 13, or 3 equals x squared minus 13. If we start solving, this is going to be positive 13. 13 minus 4 is 9. 9 is x squared. If we square root, we get plus or minus 3 as our x. And on the other side, if we add 13, that's 16. Oh, there we go. 16 is x squared. If we square root both of those, we have plus or minus 4 is x. What that does do is give us 4 actual solutions to our problem. We have on this side, we used, right, this side we had a y of -4, and on this side we have a y of 3. Since there's 2 x values, we've got a bunch of points. We have 3 comma -4. We have -3 comma -4. We also have 4 comma 3, and we have -4 comma 3. We go back to our original graph just to check it out again. Those are the points as well. We have 4, 3, -4, 3, 3, -4, and -3, -4. So part of this is sort of showing the connection between the graph and the equations and 2 ways to solve. Again, we have to remember how to solve as well here. So we're not just graphing and looking at answers, even though we are remote learning at home. Here's a different thought on this last question, which is you've already solved, or I solved for you, this system with a circle and a parabola. And like we talked about up here, there are 5 different options. They could never touch, touch once, twice, 3 times, or 4 times. This is asking you to consider what you would do to the problem and the graphs, one graph or both graph, to make this true. If you want to just mess around with the graphs, I think there is a link here on this document if you want to use it, or you can just type them in. But if we go back to Desmos and we start thinking about it, these graphs can move. So if I just start moving up my quadratic, like this right now is 4 points. If I move it, you know, where I get my vertex on exactly, it's kind of hard to do, but if I get my vertex at 0, 0, -5, I'm having trouble moving it. But if you can imagine, if my vertex is actually at 0, -5, then I would have exactly 3 intersection points. If I start moving up, I've got 2. If I keep on moving, I get to 1 if maybe my vertex is here. If I move further or just somewhere else, I've got no points of intersection. That has 2, that has 4, this has 2, that has 2, and so on. You could also move things around this way if you wanted to make the circle smaller, right? You could have a circle radius change to be within or outside of it to have no solutions. It's up to you on if you want to add. I'm not going to take the time for you to watch me record equations, but right here, if you thought about making minor adjustments, you could write new equations. Like one idea, if they had no real solutions, would be potentially like if you kept the bottom equation, y equals x squared minus 13, but maybe you made the circle have a radius of 1. It's really small, it's not going to be big enough, right? 3 solutions, I think we talked about maybe the circle staying the same and moving the parabola up so that the vertex is actually at -5. 2 solutions, right? Any vertex of that parabola being higher if you're not changing the circle size. 1 solution, your vertex of a parabola would probably be on the circle, and clearly you could flip things over. Remember, you can always solve equations to confirm your graph answers. That's like a real thing right here. So that's horrible highlighting. It's not the easiest thing, but if something had no solutions, then when you're going to solve it, you would actually find in your solution that like you can't solve the problem. Um, that's it for me. Now it's your turn to practice. So here's the questions in the book. There's only four. There's two different examples in the parent guide. If I know on one of the other videos I showed you, it's here. There are 7 pages. The first 5, I believe, are examples. The 6th page is the practice, and page number 7 is the um, answers. So that should help you out. I hope you have a good week. I will see you soon.